this computer. So when we're talking about multiples and trying to come up with equivalent fractions, we need to understand like how numbers are put together, what they're made up of. And in order to understand that, it's helpful to know your multiples, which is knowing like how to count by a number. 2, 4, 6, 8, 10 are multiples of 2. 5, 10, 15, 20 are multiples of 5. 7, 14, 21, 28, 35 are multiples of 7. So knowing your multiples helps you come up with common denominators. On the other hand, it's also helpful to know your factors. When you see a big number, it's important to know what numbers will go into that number. So a factor rainbow is if you take a number like 20, for example, and you say, what are the different ways of making 20? Well, I can do 1 times 20, right? I could do 2 times 10. 3, no, 4 times 5, right? 5, and then we're to the 5, so I know that's all of them. So these are the factors of 20. Knowing my factors means that if I see a denominator that has a 5, I know that 5 and 20 are going to have a similar denominator, that 5 will go into 20, or that 20 could be divided to make 5. That's really helpful to know. So you need to know your factors, you need to know your math facts, and you need to know your multiples in order to find common denominators. Today, I'm going to go through lesson 7.05, the lesson I was supposed to teach yesterday. And so if you haven't done that one yet, or if you're having problems with it, this will be helpful to you. I'm going to go through it fairly quickly. It's all about finding common denominators. So 7.05, if you go to math and you go to modules, yesterday you were supposed to do 7.05, but I forgot to teach it, or I taught 7.06 because I was highly confused. It's only 5 pages long. It says finding what is common. So like I said, common denominators. Paxton is mixing colors for his next artwork. Let's get in the mix to learn about adding and subtracting fractions with unlike denominators. I will be able to add fractions with unlike denominators by creating equivalent fractions. So in other words, you're not adding fractions with unlike denominators. You're changing the fraction into something with like denominators. I like to think about it like food. You can always divide food up no matter how many people are there. Let's say you each get a plate. You can divide those plates. Even though there's only 2 plates, you can take and get a 3rd plate and divide the food up, right? So let's look here. Mixing addition. Paxton is comfortable with adding 2 fractions, but to make different colors, he needs to add 3 fractions. He knows that the fractions need to have a common denominator. The first equation Paxton needs to solve is 1/2 plus 1/3 plus 1/6. So you're going to look at that 2, that 3, and that 6, and think about multiples and think about factors to see if you can come up with a common denominator that all those numbers will go into. So for example, the number of 20 is a common multiple of 2 and 10. Number 20 is also common of 4 and 5. So we just went through that one. So we need to look at this. 2 times 3 equals 6. So actually in this number, 2 will go into 6 and 3 will go into 6. So let's change them all into 6ths. Now that he's found a common multiple of 6, he can rewrite 1/2 and 1/3 as equivalent fractions with 6 as the denominator. And this is what we've been practicing. So to change 1/2 into 6, he has to ask, what do I have to times 2 by to get to 6? Well, I would times it by 3. If I times the denominator by 3, I also need to times the numerator or the top number by 3. So I'm going to multiply 1/2 times 3/3. I times the top 2 numbers together, 1 times 3, and I get 3. The bottom 2 numbers together, 2 times 3, and I get 6. Then 1/3, I do the same thing. I ask myself, what do I have to times 3 by to get my denominator of 6, to change it into 6? In other words, if I have a cake and I had cut it into 3 pieces, how many times am I going to have to cut it to get it to be 6 pieces? Well, if I cut it 2 times, or I cut the cake in half, each piece in half, I'm going to get to the equivalent fraction of 2/6. That's kind of a bad example, but just ask yourself, what do I times 3 by to get to 6? 1/3 times 2. All right. You would be cutting each piece of cake into 2 pieces, if that makes sense. So now I have 3 common denominators and I can add them together. So now I have 3 6 plus 2 6 plus 1 6, and I just add across the top the numerators together, 3, 2, and 1. I do not add the denominators together because I'm not changing the size of my pieces. This is still a cake cut into 6 pieces. If I add them together, it's like I'm cutting it again. So the denominator stays the same. You do not add those 6s together. You only add the numerators. So if you have 1 piece of cake plus 2 more pieces of cake cut into 6 pieces plus 3 more pieces of cake cut into 6 pieces, then you have a total of 6 pieces of cake cut into 6 pieces, or 1 whole cake. If I were to add these numbers, it would be like I was cutting the cake into 18 pieces and then cutting the cake into 24 pieces. And I would only have 3, 4, 5, 6 of the pieces of 24. That's not the same at all. So do not add your denominators. You never add the denominators. Okay, here's another practice one. And then when you get to the end of this lesson, there's a worksheet that is in our thing. Be very careful because some of these are subtraction and some are addition. Same thing on your worksheet. So you have to look at this. You're going to have to change them into common denominators and then remember to do the right process of subtraction or addition. So first of all, when you look at 3 and 5 and 15, which of those numbers do all the numbers go into? Well, we know that 3 and 5 both go into 15. So let's change them all into 15. Our first fraction is 2/3. To change it into 15ths, I have to times the 3 by 5. So I'm going to times the 2 by 5. And I come out with 10/15. My second fraction is 1/5. To get 5 to be 15ths, I'm going to have to times it by 3. Or if this was a cake cut into 5 pieces, in order to get 15 pieces, I'd have to cut each one of those fifths into 3 pieces to split it up between 15 people. So now I have 1 times 3 is 3. I only have 3/15. And the third fraction. Okay, the third fraction, 4/15, already has 15. Now I need to solve it. First part is subtraction. 10/15 minus 3/15 leaves you with 7/15. Now we need to add 7/15 plus 4/15 equals 7, 8, 9, 10, 11/15. Our solution is 11/15. If it comes out with a bigger number on the top than the bottom, then that means it's more than 1. And you can take out whatever the denominator is. You can take that many numbers out of the top so they're the same on the top and the bottom and make that into 1 and then have the leftover. I don't know if they're going to have leftovers on this one at all. On page 5, it says, what's my assignment? Do the assignment 7.05, finding what is common. And here's the worksheet. You can save and work on it. So if you look at our first one, we have a 4, a 3, and a 12. That's pretty easy, and it's all addition. So we're going to change them all into 12ths. On this one, a 15, a 10, and a 5. Well, you might say 15 works, but can you make 10s into 15ths? No. So on this one trick you can know is that actually 10 has 5 as a factor. So you could split this number in half, except look on the top, it's a 3. That's not going to work, is it? And the 15ths you could change into fifths too. If you could divide 15 by 3, it will get 5, and divide 6 by 3, it would make 2. So 2/5 plus 3/5. You could add those two together, but then you can't get the 10 to be it. So you're going to have to come up with something else. Let's see. What about if I double 10 to 20? Will 15 go in there? Nope. If I add one more 10 to 30, will 15 go into 30? Yep. So I think I'm going to change these all into 30ths. How about on this one? We have 3, 5, and 15 again. Let's do 30ths again. Oh no, we can do 15th on this one because 3 times 5 equals 15. Here we have 14, 7, and 2. Well, 2 times 7 is 14, so we can use 14ths. And on this one, 4 and 5 and 10. Well, 4 doesn't go into 10 equally, does it? 8 and then 12, but it doesn't go into 10 if I'm counting by 4s. Let's see, let's count by 4s and see the first time it comes to a 10. 4, 8, 12, 16, 20. Oh, there we go. Let's change them all into 20ths. And then be very careful of the subtraction and the addition. If you have any problems, come back to the main room and ask me. I'm going to stop my share. And I'm going to stop my